My name is Dr. Yanto Guy. I am a Vehicle Safety and Technology Consultant with TRL, the Transport Research Laboratory. TRL was founded in 1933 as part of the Department for Transport, and we were the research and development arm of the Department for Transport until 1996, when the company was privatised. We now operate as a non-profit distributing research and technology organisation. We're active in all types of land transport, primarily in safety, decarbonisation and improving access. In this presentation, I'm going to introduce the Code of Practice for the Operation of Automated Off-Highway Vehicles that TRL published in April this year, and which I was the lead author for. So to start off with, it's probably worth exploring what we mean by automated off-highway vehicle. First of all, it primarily operates away from open public highways. For example, highway maintenance vehicles working on a closed lane of a motorway are included within our definition of off-highway. The machine is self-propelled, the machine is land-based, so we weren't interested in things that float or things that fly. The vehicle features an automated system that can fully or partially control at least one of the operational functions of the vehicle with minimal human intervention. So that could be the driving of the vehicle, as in the directional control, but equally it could be something like an automated excavator where the human drives the vehicle around the site, but then the digging function of that excavator is automated. And finally, the automated control of the specified functions has the potential to cause direct harm to people. So this is to differentiate from control systems like engine management or something like that, where obviously there is the possibility of harm as a result of pollution or something like that. But that isn't what we mean by automated vehicle. What we mean is something where the function of the vehicle, the movement of that digger bucket, or indeed the movement of the vehicle, has the potential to do some direct harm to somebody. This of course gives rise to the question, is my Roomba an automated off-highway vehicle? And the answer is, well, probably. It meets all of the criteria. It primarily operates in locations that aren't an open public road, it's self-propelled, it's land-based, it features an automated system that controls some of the functions of the vehicle, in fact controls all of the functions of the vehicle. The final question about does it have the potential to cause harm is the important one here. So what we're saying is there is no reason why you couldn't use this code of practice for designing the safety case or for designing the operation of your automated vacuum cleaner, but perhaps you don't need to. And it is really up to the discretion of the user to decide whether the code of practice is appropriate for their application or not. TRL's experience in automated vehicles is primarily in on-highway vehicles. Now, when working on the highway, we have two enormous benefits. Our starting point is we have a highway code, and we can give that highway code to our automated vehicle and say you must obey this, and you can have a reasonable expectation that anything else you encounter, anybody else you encounter, will also be obeying it. So you should drive on the left-hand side of the road in the UK, and everybody else you meet will be driving on the left-hand side of the road. If you come to a traffic light and it's red, then you should stop, and everybody else will stop when they get to that red traffic light. We can also say to on-highway vehicles, you're not allowed to touch anything apart from the road surface. So you're not allowed to touch any humans, you're not allowed to touch other vehicles, you're only allowed to touch the road surface. And that simplifies the task of designing and operating those vehicles very much. Obviously, we're in an extremely complex environment, potentially, with a great many dynamic hazards and threats, pedestrians, other vehicles, animals, and so on. But essentially, in terms of the logic for controlling the machine, we can have a fairly simple logic that just says, don't touch anything. In off-highway applications, the situation is much more complicated. So to start off with, there may not be a road at all. If you think about a lot of the applications in which off-highway vehicles are used, there may not be a road. You may be able to drive anywhere within the site. We also struggle to enforce a rule that says you're not allowed to touch anything. So if you think about an automated excavator, or here an automated forage harvester, clearly the role of these machines, their purpose, is that they interact with things that are in the environment. In the case of the excavator, it's moving dirt around. In the case of the forage harvester, it's harvesting stuff that's in the environment, or stuff that is part of the environment. So we can't have a rule that says, don't touch anything. And that can make the problem of designing effective automated off-highway vehicles very much more complicated than the challenge of designing on-highway vehicles. What this also means is that we may wish to take alternative approaches to the way we manage these vehicles as they operate. So, in the on-highway case, it isn't possible for us to put a big fence around the site and say nobody else is allowed on our road. But for a lot of off-highway applications, we have the opportunity to put a big fence around our site and say, okay, nobody's allowed inside our site. So for things like quarries, mines, construction sites, it's entirely conceivable that we might say, we'll put a big fence up and nobody's allowed to go in there. And that gets away from the problem of interaction between humans and automated vehicles. In putting together our code of practice, as a starting point, we had two key documents. So the first is HSG 136. This is the Health and Safety Executive's Guide to Workplace Transport. This is the guide to what can I do with vehicles in my workplace, and effectively sets out the rules for non-road vehicles. And we also have the Centre for Connected and Autonomous Vehicles code of practice for the trialling of automated on-highway vehicles. And this has become very much the kind of the main top-level piece of guidance for organisations that are trialling on-highway automated vehicles. Now, there is a big gap in between these two documents, in that HSG 136 deals with workplace transport, but doesn't deal with automation, and the CCAV Code of Practice deals with automation, but doesn't deal with the off-highway stuff. So we have a gap to fill between these two documents, and this is where our Code of Practice fits. So what changes because we're automated now? So the first thing that changes, and perhaps slightly counterintuitively, is human factors. We've all been used to a set of human behaviours from human drivers. You put an operator into a machine and you expect them to behave and to fail in certain ways. As we start to adopt automated machines, that interaction between machine and human can change in a myriad of ways. So we might choose to put an operator into the machine, have a driver in the machine, but the responsibilities of that driver are going to be new and different. So we might, for example, if you consider an agricultural example, have a machine that is capable of driving itself up and down the field, but is reliant on the human driver to do collision avoidance. Humans are not good in situations where they have to supervise things. They get bored, they doze off, they start surfing on Facebook and so on. So it's very important to have in place systems for dealing with the behaviour of the human. And it isn't okay to simply place the onus of responsibility onto that human driver. We can't simply divest an organisation of its safety responsibilities by saying, well, now it's the responsibility of the person in the cab, as we might have done previously with wholly human-driven vehicles. Cybersecurity obviously becomes really important. It would be a relatively straightforward business to be able to steal an automated vehicle by simply taking over its control system and driving it off. There is also obviously a great opportunity for causing mischief for various purposes. So you can imagine that the consequences, for example, of taking over an automated bulldozer and driving that off a site and into a town or up a motorway or something like that could be very serious. Site design becomes really important. I mentioned that we might want to choose to put a fence around our automated vehicles, and we might want to segregate our automated vehicles from human-driven vehicles or from other human operations. So we might have a playpen where we keep all of our automated vehicles, where effectively we can control access to that playpen, we can keep the humans out of it, and that improves the safety of that operation. Next up, incident recording and analysis. This becomes really important because something that might be completely inconsequential in a human-driven vehicle might actually be a symptom of something much more dangerous in an automated vehicle. So, for example, if you require a vehicle to stop at a certain point and your human driver misses that point by half a metre, well, that's just the kind of ordinary human variability that we might expect and isn't indicative of anything more sinister. Whereas for an automated vehicle, if it occasionally misses that stopping point, that could be a symptom of a sensor failure, a control system failure. So it's important to capture those seemingly innocuous failures in order that they can be analysed to determine whether we have an incipient failure developing within the machine. The final thing is change control, and this is really important for manufacturers to understand as well as for users of machines. So, for example, if you do over-the-air software updates that change the behaviour of the machine in some way, it's really important that you communicate that change and that the user, the operating company, has some control over when those changes are implemented and how they are implemented. It's really important to understand what changes are being made, to record them and to understand the consequences of them. Because again, a relatively minor change to one vehicle within a system, where vehicles may be interacting with one another and maybe cooperating with one another, could have potentially serious knock-on effects for the whole operation of the system. So the Code of Practice itself is a 40-page document. It's split up into 3 main sections, and it's available to download for free from the TRL website. We have created this very much as a community resource. This is in response to a request from industry, who have said at the moment there really is no guidance on what we ought to be doing with automated systems. And until there is effective guidance, it is very difficult to implement automated systems in the workplace. So this first attempt, this first draft from TRL, is really an attempt to codify what ought to be happening in the operational environment. The document is split up into 3 sections. The first section is really a guide to how to use the Code of Practice, what it should be used for. Section 2 deals with the key concepts and the concepts that might be new to the operators of automated off-highway vehicles. The third section is really all about implementation and the systems that you need to have in place in order to make your off-highway system work effectively. And by system here, I'm talking about the organisational systems, the behaviours and so on that you need to adopt in implementing your automated system. There really isn't time in this presentation to break this down in a great deal more detail, so I recommend that you go and get a copy of the Code of Practice and have a look through. When you go to that link on our website, there is also a much longer webinar. We ran a 3-hour seminar with some of our stakeholders from industry, where we discuss the development of the document in a great deal more detail and also provide a few examples of what's going on in the automated off-highway industry. So finally, I must acknowledge the contribution of the team who put this document together. We had a big TRL team. I must also acknowledge Innovate UK, who provided the financial support for the development of the document. Oxbotica, who were a partner in the project that we were working on, and everybody who contributed to the stakeholder engagement. We really valued the contribution that we got from our friends in the industry. Finally, my contact details are there. If you want to get in touch to discuss the Code of Practice or indeed the broader world of automated off-highway vehicles, then please do so. Thanks very much for your attention.